Hello, this is Dr. Liu, and in this video I want to show you how to use a breadboard or a solderless breadboard. I have two breadboards here. So the one on the left, I have some components. Basically, I built a circuit, and I have some spare components just to keep them from losing them. And on the right side, I have a blank breadboard, so I can show you how this thing works. If I flip this to the bottom side, here's actually some adhesive backing. It's adhesive on both sides. So one side is already glued to the back side of the board. The other side, if you peel the backing off, you can adhere it to some smooth surfaces. So let's take a look at how this board works. So let's bring this in. You can see there are numbers and also letters. So here, I think the okay, camera is having some trouble focusing because this breadboard is almost transparent. So you can see some letters A, B, C, D, E, then there's a gap, F, G, H, I, J, and there's also numbers here. Difficult to see the 1 right here, but then there's 5, 10, 15, 20, so they're all marked all the way down to 60, 61, 62, 63. Okay, 63. All right. And there's also some plus minus signs over here. Plus in red, minus in blue. Okay, so how do I use this? First of all, I want to show you that the breadboard is not just one piece construction. It's made of several pieces. Like this one actually comes off. These are the buses. This part also comes off. Okay. So these are separate from those. Okay, so how do I use this centerpiece? All right, so here's how you use the centerpiece. See the A here, A, B, C, D, E, on the, row 1. They're all connected together because if you flip it to the back side, oh, you can see there are these strips of metal. These are actually metal clips that are behind these holes. Every row of 5 holes has one shared metal clip. So I already loosened this one up. All I have to do is to stick my jeweler's screwdriver and pull this out. So here's what it looks like behind the 5 holes. It's a set of 5 little clips. So you can insert a wire right here. So you'll hold that wire, and if you can insert, you can insert up to 5 different wires of even different sizes, right? They're individually clips, but they're all together as one piece metal construction. So that's what's behind A1, actually A1 through E1. So all these 5 are connected. All the A2 through E2 are connected, and there's a gap here. As you can see, there's no metal in between. There's nothing in the gap. So the left 5 and the right 5 are independent of each other, and each row is an independent clip. So you can push it out to inspect it, but everything looks the same as that clip with 5 pairs of prongs to hold on to wires. So let's look at these buses. Well, I loosened up this right here, and as you can see, there's some clips in here as well. I don't want to break it, but this is a one-piece construction. As you can see, this is one continuous piece of metal, and every 1, 2, 3, 4, 5 holes have 5 clips. There's some space, but the clip is one continuous piece of sheet metal, right? So all of these reds are connected together, and all the blues are connected together. Are the left and the right reds connected to each other? They're not, because they're just separate pieces, right? So let me push this one back before I break it. If I break it, then I have to solder the metal together. So, okay. So now that you know how these are constructed, how do you use them? Okay, so use them this way. So if you want to connect something, you can draw a diagram, say two resistors are connected in series. So how do you do that? Well, that means, let's just say we're going to lay out the resistors vertically. So that means the top leg of the top resistor is on its own, and then the bottom leg of that resistor has to somehow connect to the top leg of the bottom resistor. So how do you connect? Well, all you have to do is share one row of holes. Then you're connected to the other resistor. So let me grab some random resistors. Okay, so here's a bunch. That actually came out of one Arduino kit. I don't know how they're able to get that many resistors there, but okay. So let's say that we're going to make two resistors in series. I'll start with A1. This is just my own choice. You don't have to do that. A1 through A11. So this is a whole thing with what 10 holes apart. Each hole is actually a 0.1 inch of spacing. So A1 to A11 there. Okay, so if I want the next resistor to be in series with the first one, I have to start with the 11th row. But the A11 is already taken, so I start with B11. And this one, I'll just go to B17. So let me put this down and push the legs in so I can show you. So the second resistor is on, well, B11, and the first resistor is on A11. Remember, A, B, C, D, E are all connected on the 11th row, so that makes these two legs connect. You don't have to physically twist the two legs together, which doesn't really make very good electrical contact anyway. And this one is over here. So they're in series in between these 2 points, where you can put some wires, say on the row 1, on row 17, and then you can connect to a power source. Okay, so that's how you put things in series. The two legs that are supposed to be connected to each other will share this junction. So each row of 5 pins is a junction. Okay, so how do you make things in parallel? Let's just say that I want to add another resistor in parallel with the first resistor. That means between row 1 and row 11, I want to put in another resistor. So let me just get a resistor to approximately correct spacing. Okay, there. So I'm just going to put this in C1 and C11 because well, B11 is already taken by the bottom resistor, so this looks like the two are parallel because they are connected to the same rows here. The row 1 here, also same row 11. And the two equivalent will be in series with that. So this is how you put things in parallel. Use the same row here for one side, use the same row for this other side. So let's try to connect something on the breadboard incorrectly. So let's take another resistor and try to space its leg close enough. So I'm just going to put it here, maybe 25. Okay, A25. Oh, it's hard to hold it in space. Try to push these in. Pretty good clips. Okay, so here it is. It's between A25 on the left and well, E25 on the right. Well, what's wrong with this? Well, both legs are actually on the same clip. They're shorted. So this is unless you're just keeping the resistor here from losing it, this is not going to do anything. So that's the same as twisting the two legs together, right? So that's mistake number 1. Okay, so what else can you do? Well, you can try to maybe overstretch a resistor's leg, for instance. You don't have to. You have jumper wires that can jumper from one place to another. So you don't want to just overstretch your resistors. And also you don't have to put your resistors flat against the breadboard. That would look very nice, but it would also require you to trim the legs to the exact lengths, which means they may not be useful for the next project when they're no longer at the right lengths, right? So this is how you would put things on the breadboard. And here, the groove here. The purpose of having this groove is to have an integrated circuit inserted here between the left and the right, because it'll cover up some of the holes. If there were holes in the groove, an integrated circuit like this Arduino's processor could be inserted here. Right, so let's do that. Although I won't be well, actually using that setup, I can certainly insert it. Okay, so I have here an IC puller. The resistor, the integrated circuit puller has these two claws that are like this, right? So they can be inserted underneath the IC and gradually loosen it. Don't want to try to pull it really hard. Just loosen one end at a time, and the other kind of rock this thing, and you'll eventually get it out. Hopefully I'll get it out there without damaging it. So the resistance is always like that. It'll suddenly release. All right. So I have this. This is it's interesting. Someone has already kind of bent the legs to the correct distance, which is 0.3 inches apart. So you can take this, for instance, insert it between 21 and 34. So what's that? That is 28 pins, 14 pins on each side. So just push it in. There we go. So now that each leg has occupied one hole here, there are still 4 holes that you can connect to this same leg, right? Still 4 holes here you can connect to this leg, which itself occupies one hole. All right, so that's how you use the center, is to place integrated circuits. And some people also use the center like this. They really want to build resistors horizontally. They would do it this way. So kind of straddle this between, say, 40 H and 40C, for instance. So this is okay because the two legs are on 2 different rows, left side row and right side row. And as we can see, they're on 2 different clips. Right? There's nothing in between connecting the clips. So you can connect to these resistors either side leg using other resistors or jumper wires. All right. So that's how some people would actually do it. If you're using jumper wires that are not the ones that are just that are color, well, I wouldn't say color coded. They have color sheath, and you can basically do anything with it. But there are also other type of jumper wires where the color indicate the length of the jumper wires. So if you want to go from a distance to a location to another location, say if that's a 5-hole distance, so from 40 to 1, 2, 3, 4, 5 to 45, for instance, then you need a 0.5 inch distance jumper wire. That would be a green one. So that is some of the one of the same things that some people may complain about, color coding with numbers such as green equals 5, right? So I think this is good enough introduction for how to use a breadboard. Hopefully this is helpful. Took me a while to get the adhesive backing off and remove all the remnant, so this looks shiny on the back side.